Okay, so in this video we will take a look at this question of differentiability of a piecewise function. So let's say we have the following function f of x defined as 2x minus 1 if x is greater than or equal to 0, and x squared plus 2x minus 1 if x is less than 0. And the question is this function differentiable at x equals 0? Does it have a derivative at x equal to 0? So is f differentiable at x equal to 0? That's the question we would like to answer, which is equivalent to saying basically, does f dash at 0 exist? Does this function have a derivative at x equal to 0? First, note that the function is continuous at x equals 0. The limit from the left is minus 1. Limit from the right is also minus 1. F is continuous at x equals 0. Therefore, it may be differentiable. We're not quite sure. Now, so what we want then is to see whether this derivative exists. And of course, the derivative, by definition, is the limit as x goes to 0 of f of x minus f of 0 divided by x minus 0. So we want to see, does this limit exist or not? Okay? Because the function is defined in two different ways, from the right as 2x minus 1, from the left as x squared plus 2x minus 1, then it is necessary to look at the limit from the right of this expression so it's the limit as x goes to 0 plus, basically, which means that x is greater than 0. So I need to look at the first expression for the function. So 2x minus 1 minus, okay, now this is f of 0, yeah, and f of 0 will come from here because x greater than or equal to 0. So 2 times 0 minus 1, which will give us minus 1. So that minus 1 comes here over the x. And that limit, of course, minus 1 plus 1, so that is just 2x over x as x goes to 0 plus, and the x with the x will simplify. So the limit from the right is equal to 2. Now we need to consider the limit from the left. Limit as x goes to 0 minus of f of x minus f of 0 over x minus 0. So it will be the limit as x goes to 0 minus, this time the function is x squared plus 2x minus 1, and then minus 1, f of 0 still minus 1 over the x. And now this expression 0 minus minus 1 plus 1 will go, so it will be x squared plus 2x over x, which we can factor. The numerator can be factored into x plus 2 over x as x goes to 0 minus. Now this x and this x will go, and this limit is also equal to 2. Therefore, what we have shown is that the limit as x goes to 0 of f of x minus f of 0 over x minus 0 exists, and it's equal to 2, and therefore f is differentiable at 0, and not only that, but its derivative at 0 is equal to 2. So that is our conclusion in this question.